Ever wondered how those simple circles and shapes can unlock the logic behind every math set? Let's explore Venn diagrams where geometry meets pure logic. A Venn diagram shows the relationship of sets in the form of a diagram. It consists of a rectangle and circles within it. A rectangle represents the universal set and is usually indicated by this symbol. Circles within the rectangle indicate subsets. Subsets, complement of a set, union, and intersection of sets, can be represented in a Venn diagram. Let's start with how to represent subsets in a Venn diagram. A subset is a set in which all its elements are members of another set. It is denoted by this symbol. To represent a subset in a Venn diagram, a subset is placed inside another circle. To illustrate, this image depicts two sets, set B and C. Set C is inside B, so set C is a subset of set B. For example, given that the universal set has elements 1 to 10, set Z has elements 1 to 6, and set Q has elements 1, 2, and 3. Show the sets in a Venn diagram. First, draw a rectangle to represent the universal set. All the elements of set Q are also elements of set Z, so set Q is a subset of set Z. Set Q has elements 1, 2, and 3. Set Z has elements 1 to 6, but elements 1 to 3 are already in set Q. The remaining elements 4, 5, and 6 has to be inside set Z but outside set Q because they are members of set Z but not members of set Q. Finally, the universal set has elements 1 to 10. Elements 1 to 6 are already taken up by sets Z and Q. Then the remaining elements 7, 8, 9, and 10 has to be outside both sets but inside the universal set. This is a Venn diagram representation of the given sets. Next, the complement of a set. The complement of a set is a set of all elements in the universal set that are not in a given set. It is denoted by C with an apostrophe. To illustrate, this image depicts the universal set and set C. The complement of set C are all elements in the universal set but not in set C. To represent the complement of a set, find all elements that are not in a given set but are part of the universal set. For example, given that the universal set has elements 1 to 10 and set D has elements 1 to 4, show the sets in a Venn diagram and find the complement of set D. Always start with drawing a rectangle to represent the universal set. Set D has elements 1, 2, 3, and 4. Then elements 5, 6, 7, 8, 9, and 10 has to be outside set D but within the universal set. The complement of set D are all elements in the universal set that are not in set D. That is elements 5 to 10. So the complement of set D is equal to 5, 6, 7, 8, 9, and 10. Next, the union of sets. A union of sets is a set formed by combining all elements of the given sets. It is denoted by this symbol. To illustrate, if two sets are E and F, the union of set E and F is obtained by combining all elements of set E and set F. The union of set E and F is denoted by this. For example, given that the universal set has elements 1 to 10, set X has elements 2, 3, 4, and 5, and set Y has elements 6, 7, and 8. Show the sets in a Venn diagram and find the union of set X and Y. First, the universal set. Set X has elements 2, 3, 4, and 5. Set Y has elements 6, 7, and 8. The remaining elements, 1, 9, and 10, are part of the universal set but are neither members of the two sets, so they have to be outside the two sets but within the universal set. This is the Venn diagram representation of the given sets. Write the union of set X and Y in the comment section. Finally, the intersection of sets. The intersection of sets is a set of common elements which belong to the given sets. It is denoted by this symbol. To illustrate, if two sets are G and H, the intersection of set S and T are elements belonging to both set G and set H. For example, given that the universal set has elements 1 to 10, set M has elements 2, 3, 4, 5, and 6, and set N has elements 5, 6, 7, and 8. Show the sets in a Venn diagram and find the intersection of set M and N. First, the universal set. Elements 5 and 6 are members of both sets. So the two sets has to intersect with elements 5 and 6 shared by both sets. Then set M takes up its remaining elements 2, 3, and 4. Also set N takes up its remaining elements 7 and 8. Elements 1, 9, and 10 are part of the universal set but are neither members of the two sets, so they have to be outside. This is the representation of the given sets in a Venn diagram. The intersection of set M and N is equal to 5 and 6. A Venn diagram doesn't just show sets, it reveals relationships, logic, and structure behind how data connects. Once you master it, you see patterns everywhere, even beyond mathematics. Now that you understand how Venn diagrams represent subsets, unions, intersections, and complements, in the next video, we'll explore fractions. Stay tuned. Stay curious.